This is the UNI-T UT203R clamp meter. The main goal of this video isn't to measure AC or DC current. The goal is the reason why we zero the clamp meter, how orientation affects the result, what common mistakes look like in practice, and why clamp meters sometimes display values that seem incorrect. These details are often missing in typical tutorials. Today we focus on measurement principles and real-life behavior. A clamp meter measures magnetic field. When current flows through a conductor, a magnetic field creates around it. The clamp senses that field and converts it into a current value. AC current measurement is the original function of clamp meters. DC measurement is possible because this instrument contains Hall effect sensor module. The jaws are designed for current measurement. Other quantities require test probes.
Okay, here I have a laboratory power supply connected to an electronic load that gives stable and controllable DC current. It is a clean environment for demonstrating measurement behavior. Before measuring DC current, the meter must be zeroed. The jaws must be fully closed and the meter should be away from the conductor. If the clamp is zeroed too close to a live conductor, part of its magnetic field becomes a reference. A distance of roughly 20 to 30 centimeters is usually sufficient in small current systems. The meter should be zeroed in the same orientation in which it will be used for measurements. If you rotate it afterwards, the reading may shift due to the Earth's magnetic field and internal sensor characteristics. The electronic load is set to 3 amps. Now I clamp around only one conductor. The measured value can now be compared with the set current on the electronic load and set the indication on the power supply. When both positive and negative conductors are inside the jaws, their magnetic field cancel each other. The result is close to zero. The current still flows, but the magnetic field simply cancels. At lower DC currents, measurement error becomes more visible. A small offset of 0.1 amp represents more than 10% when measuring 0.8 amps. For AC current, clamp meters use transformer principle. Zeroing is typically not required in AC mode. Instead of cutting and stripping cables, I will demonstrate the principle using a sample conductor. First, a single-phase conductor. The clamp surrounds one conductor and the magnetic field can be measured correctly. Now a cable containing Ln and Pe. If the clamp surrounds all conductors together, the magnetic fields cancel. Proper measurement requires isolating one conductor inside the jaws. The conductor should be positioned near the center of the jaws for the best accuracy. Geometry affects the result.
Clamp meters are optimized for moderate or higher currents. Below roughly half an ampere on a 40 amp range, noticeable relative error should be expected. They are excellent diagnostic tools, but not precision laboratory instruments for very small DC currents. This instrument can measure voltage, resistance, and additional parameters using test probes. A clamp meter measures magnetic field. AC measurement is its natural operating mode. DC measurement requires correct zeroing and consistent orientation, one conductor inside the jaws, stable positioning, awareness of low current limitations. If these principles are respected, the readings become predictable and reliable. This is Emergency Power Lab. Thanks for watching and see you in the next video.